Hello everyone. Today our MBA topic is cloud computing in emerging technologies in global business environment. What is cloud computing? Cloud computing is on demand access to computing resources, physical or virtual servers, data storage, networking capabilities, application development, tools, software, AI powered analytics platforms, and more over the internet with pay per use pricing. In simpler terms, the cloud doesn't refer to something floating in the sky. Instead, when you use cloud services, you are accessing remote servers, powerful mainframe computers housed in large data centers through the internet. The cloud computing model gives you the customer greater flexibility and scalability compared to traditional on premises infrastructure. Cloud computing is pivotal in our everyday lives, whether that means to access a cloud application such as Google, Gmail, stream a movie on Netflix, or play a cloud hosted video games. With cloud computing, you get the computing power or storage you need without having to own or manage the physical hardware yourself. Cloud computing has also become indispensable in business settings, from small startups to global entrepreneurs or enterprises, as it offers greater flexibility and scalability than traditional on premises infrastructure. Its many business applications include enabling remote work by making data and applications accessible from anywhere, creating the framework for seamless omni-channels or omni-customers engagement, and providing the vast computing power and other resources needed to take advantage of cutting edge technologies such as generative AI and quantum computing. Now, benefits of cloud computing compared to traditional on premises IT, where a company owns and maintains physical data centers and servers to access computing power, data storage, and other resources. Cloud computing offers many benefits, including cost effectiveness, increased speed and agility or agility, unlimited scalability, enhanced strategic value. First, cost effectiveness. Cloud computing lets you offload some or all of the expense and effort of purchasing, installing, configuring, and managing mainframe computers and other on premises infrastructure. You only pay for cloud based infrastructure and other computing resources as you use them. Increased speed and agility. With cloud technologies, your organization can use enterprise applications in minutes instead of waiting weeks or months for IT to respond to a request, purchase, and configure supporting hardware and install software. This feature empowers users, specifically DevOps and other development terms, to help or teams to help use cloud based software and support infrastructures. Unlimited scalability. Cloud computing provides elasticity and self service provisioning. So instead of purchasing excess capacity that sits unused during slow periods, you can scale capacity up and down in response to spikes and dips in traffic. You can also use your cloud provider's global network to spread your applications closer to users worldwide. Enhanced strategic value. Cloud computing enables organizations to use various technologies and the most up to date innovations to gain a competitive edge. For instance, in retail, banking, and other customer facing industries, generative AI powered virtual agents developed over the cloud can deliver better customer response time and free up teams to focus on higher level work. In manufacturing, teams can collaborate and use cloud based software to monitor real time data across logistics and supply chain processes. Now, origins of cloud computing. The origin of cloud computing technology go back to the early 1960s when Dr. Joseph Carl Robnet Linkter, an American computer scientist and psychologist known as the father of cloud computing, introduced the earliest ideas of global networking in a series of memos discussing an computer network or intergalactic computer network. However, it was not until the early 2000s that modern cloud infrastructures for business emerged. In 2002, American Web Services, cloud based storage and computing services. In 2006, it introduced Elastic Compute Cloud, that is EC2, an offering that allowed users to rent virtual computers to run their application. That same year, Google introduced the Google Apps Suite, now called Google Workspace, a collection of SaaS, SaaS productivity applications. In 2009, Microsoft started its first SaaS application, Microsoft Office 2011. By 2028, Gartner predicts cloud suites or shifts from being an industry disruptor to becoming a business necessity and an integral part of business operations also. Now, cloud computing components. First, data centers, then networking capabilities, then virtualizations. First, data centers. CSPs own and operate remote data centers. that house physical or bare metal servers, cloud storage systems, and other physical hardware that create the underlying infrastructure and provide the physical foundation for cloud computing. Networking capabilities. In cloud computing, high speed networking connections are crucial. Typically, an internet connection known as a wide area network, that is WAN, connects front end users, client side interface made visible through web enabled devices, with back end functions, that is data centers and cloud based applications and services. Other advanced cloud computing networking technologies introduce or including load balancers, content delivery networks, that is CDNS, and software defined networking, that is SDN, are also incorporated to help ensure data flows quickly, easily, and surely between front end users and back end resources. Now, virtualization. Cloud computing relies heavily on the virtualizations of IT infrastructure, servers, operating system software, networking that's abstracted by using special software so that it can be pooled and divided irrespective of physical hardware boundaries. For example, a single hardware server can be divided into multiple virtual servers. Virtualizations enables cloud providers to make maximum use of their data center resources. Now, cloud computing services. Infrastructure as a service, that is IaaS, platform as a service, PaaS, software as a service, or SaaS, serverless computing, are the most common as a service cloud platform models. Most developers at large scale organization use some combination of all four. IaaS offers full control over IT infrastructure, allowing organizations to build and manage systems. PaaS builds on IaaS by providing a platform that simplifies the development and deployment of applications, handling the underlying infrastructure for you. SaaS says the most widely used cloud service delivers ready to use software, removing the need for management, and serverless computing built on IaaS and PaaS lets you focus solely on writing code. Now, IaaS, infrastructure as a service. Infrastructure as a service, IaaS provides on demand access to fundamental computing resources, physical and virtual servers, networking, and storage over the internet on a pay as you go basis. IaaS enables users to scale and shrink resources on an as needed basis, reducing the need for high upfront capital expenditures or unnecessary on premises or owned infrastructure and for overbuying resources to accommodate periodic spikes in uses. According to a support from the business research company, the IaaS market is predicted to grow rapidly in the next few years. Now, PaaS, platform as a service. Platform as a service, PaaS provides software developers with an on demand platform, hardware complete software stack, infrastructure and development tools for running development and managing applications without the cost, complexity, and inflexibility of maintaining that platform on premises. With PaaS, the cloud providers host everything at their data center. These includes servers, networks, storage, operating system software, middleware, database. Developers simply pick from a menu to spin up servers and environments they need to run, build, test, deploy, maintenance, update, and scale applications also. Today, PaaS is typically built around containers, a virtualized compute model, one step removed from virtual servers. Containers virtualize the operating system, enabling developers to package the application with only the operating system services it needs to run on any platform without modification and the need for middleware. Now, SaaS, software as a service. Software as a service, SaaS, also known as cloud based software or cloud applications, is interactive applications software hosted in the cloud. Users access SaaS through a web browser, a dedicated desktop client, or an application programming interface, that is API, that integrates with a desktop or mobile operating system. Cloud service providers offer SaaS based on a monthly or annual subscription fee. They can also provide these services through pay per use pricing. In addition to the cost savings, time to value, and scalability benefits of the cloud, AWS SaaS others or offers the following. First, automatic upgrades. With AWS SaaS, users have access to new features when the cloud service providers adds them without having to uh, orchestrate and on premises upgrade. Protection from data loss, because AWS SaaS stores application data in the cloud between the application. Users don't lose data if their device crashes or breaks. AWS SaaS is the primary delivery model for most commercial software today. Hundreds of SaaS solutions exist, from focused industry and board administrative, for example, Salesforce, to robust enterprise database and artificial intelligence AI driven software tools. Now, serverless computing, or simply serverless, is a cloud computing model that offloads all the back end infrastructure management tasks, including provision or provisioning, scaling, scheduling, and patching to the cloud providers. This capability frees developers to focus all their time and effort on the code and business logic specific to their application. Moreover, serverless runs application code on a per request basis only and automatically scales the supporting infrastructure up and down in response to the number of requests. With serverless, customers pay only for the resources used when the application runs. They never pay for idle capacity. Function as a service FaaS, FaaS is often confused with serverless computing when in fact it's a subset of wireless. FaaS allows developers to run portions of application code called functions in response to specific events, everything besides the code, physical hardware, virtual machines, VM, operating system, and web servers software management is provisioned automatically by the cloud server or service provider in real time as the code runs and is spun back down once the executions is complete. Billing starts when execution starts and stops when execution stops. Now, types of cloud computing. Public cloud. A public cloud is a type of cloud computing in which a cloud service providers makes computing resources available to users over the public internet. These include SaaS applications, individuals, virtual machines, that is VMS, bare metal computing hardware, complete enterprise grade infrastructures, and development platforms. These resources might be accessible for free or according to subscription based or pay per use pricing models. The public cloud providers owns, manages, of assumes all responsibility for the data centers and hardware and infrastructure on which its customers' workloads run. It typically provides high bandwidth network connectivity to help ensure high performance and rapid access to application and data. Public cloud is a multi tenant environment where all customers pool and share the cloud provider's data center, infrastructure, and other resources. Now, private cloud. A private cloud is a cloud environment where all cloud infrastructure and computing resources are dedicated to one customer only. Private cloud combines many benefits of cloud computing, including elasticity, scalability, and ease of service delivery with the access control, security, and resource customizations of an premises infrastructure. A private cloud is typically hosted on premises in the customer's data center. However, it can also be hosted on an independent cloud provider's infrastructures or built on rented infrastructure housed in an offsite data center. Many companies choose a private cloud over a public cloud environment to meet regularity appliances requirements. Large scale entails, such as government agencies, healthcare organizations, and financial institutions, often opt for private cloud settings for workloads that deal with confidential documents, personality, and identifiable informations, that is PII, intellect or intellectual property, medical records, financial data, or other sensitive data. By building private cloud architecture according to cloud native principles, organizations can quickly move workloads to a public cloud or run them within a hybrid cloud environment whenever ready. Now, hybrid cloud. What is hybrid cloud? A hybrid cloud is just what it sounds like, a combination of public cloud, private cloud, and on premises environment. Specifically, the ideally a hybrid cloud connects a combination of these three environments into a single flexible infrastructures for running the organization's applications and or workloads. At first, organizations turned to hybrid cloud computing models primarily to migrate portions of their on premises data into private cloud infrastructure and then connect that infrastructure to public cloud infrastructure hosted off premises by cloud vendors. These processes was done through a packaged hybrid cloud solutions such as Red Hat OpenShift or middleware and IT management tools to create a single pane of glass. Teams and administrators rely on these unified dashboard to view their applications, networks, and systems. So that's the end of the video, my friends. If you like my blogs, please subscribe my channel, and also you can comment and share it. Thanks again for your precious time for watching my videos.